Hello everyone, hope you are doing well. Welcome back to AWS DevOps Lokesh Tech YouTube channel. In this channel, you might see lot of playlists regarding all these playlists like AWS, Linux, Docker, Shell scripting, Kubernetes, Terraform, Jenkins, Ansible, and Python and OpenShift. Now we are going to discuss about a new topic which is Kafka. Okay, let's see what is Kafka and all. So we will discuss more about Kafka. So this what is Kafka and all. So we'll see one by one. So first of all, so this guy actually introduced by Kafka. Actually, what is event streaming? So what can I use event streaming for? What is Apache Kafka is an event streaming platform. Okay, how does Kafka work in nutshell? Okay, main concept of terminology. This is a official documentation. What is it for? All those things you will be able to see in this official documentation. You see, if you go and see, you can able to read about Kafka contents. See documentation. So getting started, introduction of what is event streaming, what is what can I use event streaming for? Okay, Apache Kafka and all. So see the documentation APIs. What is the API? Introduction of API. What is the relation between Kafka and API? And designs. You see, right? So design motivation, everything, correct? So you can read this much better because you can able to understand very much well using this documentation, because official document always give you a perfect output. Okay, perfect information, right? So a lot of, you see, security clients, Kafka connect, how to connect with Kafka, all those, right? And other one is Kafka streams. What is Kafka and streams? See, with the Kafka streams, you see, so all these things are there in this Kafka streams. So, so all these things, if I read, it takes too much time, right? So I prepared one PPT for Kafka. So let's go through with a real-time example. Okay. So what is Kafka? Understanding Kafka with a real-life example. Let me explain Kafka in a way that makes everything finally clicks for you. Okay. So imagine we are building a e-commerce a platform called a stream store. So you just understand. So we are building a e-commerce website called stream store. So like any online store, we have a different services handling payments, right? Orders, inventory, so on. So now think about what happens when a customer places an order. Okay, so it's just like ordering pizza. Like, so once if you order, a whole series of actions get triggered behind the scenes, correct? So the stocks needs to be updated in the database. A confirmation email sends to the customer, right? Yeah. An invoice needs to be generated with the correct sales tax and email to the customer. Sales and revenue dashboards needs to be updated in real time. Okay. So like, for example, inventory, notifications, billing, analysis, some kind of all these steps are involved, and finally you'll be generated one invoice, right? Okay, so at first, since we just a small startup, for suppose, so we have established one startup company. So we keep things simple. Our microservices talk directly each other. Okay, the order services simply notifies all the other services. Okay, and this works great at first. Okay, but then even start gaining traction. People love our store, okay, or maybe announce Black Friday sales or whenever it peaks, and suddenly our site is flooded and hundreds of thousands of customers, right? So too much traffic continuously getting to your site, and just like that, things start falling apart. The problem with the direct communication with a sudden spike in a traffic, all of a sudden it increases visiting your application, okay, by users or customers or whatever. So our application slow down, right? Customers are stuck in the loading six screens like this, correct? So our services start crashing between crashing, right? Definitely, because they are too depend on each other. Okay, it continuously. For example, today is actually for example, today is World Cup. Okay, so normal days, Hotstar, the people will watch. Uh, normal days, what will happen is they will watch for movies, they will watch for some kind of activities in the Hotstar. But so in the World Cup time, entire world will directly open to this Hotstar. They will use the service from Hotstar, and that application. What happens is if all of a sudden all people open at a time, so the load will be increased on top of this application. So what will happens? All of a sudden it increases, correct? So the load, whenever it load increases, automatically the application will goes down, right? It will get stuck, right? So that for to balance that, we have other concept called Kubernetes and OpenShift, but that is not a topic right now. So right, these things will happen, right? You can understand, for understanding, for better understanding, we can take it as an example, World Cup, right? So then entire order process freezes. So for example, so these kind of Hotstar, it's like raw dominoes. Okay, for example, dominoes are there. So for example, rainy season, at that time you can't go outside, so you can't get it, the you can't get it food, all those things. So what happens? So you will try to use a Zomato or something, or Domino's pizza related e-commerce websites. Then what happens, at the time their application will goes down, right? Okay, so it's, so what happens, the problem is direct communication with the sudden spike in the traffic. Application slows down, customers stuck on loading screens, right? Our services start crashing. Two depend on, it's all because of two depend on each other. Example, again I'm telling, repeating the example. If the payment services goes down, so maybe because some external API isn't responding properly, on the service itself crashes under load, then other entire order process freezes, right? It's like a raw, it's like a Domino's pizza, Zomato, something like this. Okay, everything is stuck, right? So this is called tight coupling. This is called as tight coupling. Okay, what does it mean? See, this is payment process. Okay, these are all orders. Orders are ready. Okay, need to go notifications, inventory, analysis. So all these things, these are all actually one connecting each other. This is called tight couple. What is tight coupling? So each service directly calls the other. Okay, so which means dependency. So if service is unavailable or slow, entire process will be disrupted. Okay, which means it is depending on either other. It is depending on other. For example, like a series connection, for suppose, one after the other, one after the other, one after the other. Okay, this is completely depending on each other. For example, if it is one fails, automatically the other will not work properly or it will be stopped. Okay, this is called as tightly coupled, right? So yeah, so each service directly calls the other, right? That is called as tightly coupled. This tightly coupling all services are too dependent, and that's not only the problem. Okay, if the inventory services crashes for 10 minutes, it caused 2 hours of order backlogs and countless lot sales. Okay, if the analytics services goes down, we lose crucial Black Friday, like sales data that will never recover. The entire system breaks down under the pressure and we start losing money and every minute. Okay, this architecture, which looks so simple and clean and on a whiteboard, has it become a nightmare in reality. Okay, so it's okay, but while you are seeing everything is on top of the screen, it is easy to understand, but in the real time it's kind of, you know, you can't imagine what happens. So background, right? Hmm? So it's never recover that much, not that much easy. Okay, the solution is actually for decoupling all these services using Kafka. Okay, so synchronous means connection. Service operate linear step by step process. That's what I showed now. Okay, so to synchronizing process is not proper. That's not correct, right? So a 10-minute inventory service outage means 2 hours of or order backlogs, right? Losing data, lot of business you will lose. Okay, so in this point, so we can give the solution kind of. So decoupling with the Kafka. So what is the fix? So how to fix it? Hmm? Instead of letting our orders bounce between services like a hot potato, so what if made them flow smoothly like a conveyor belt? You know, conveyor belt in power plants. So conveyor belt will be there. So it will move on. The things, whatever the coal is moving continuously, moving without any stoppage. So it will reach to the destination for boiled house. Okay, boiler. In that boiler, it will fire. That's okay. Just conveyor belt means this, just giving a small example. So which means flowing, the flow, continuous process without any disturbances. Okay. So instead of making services talk directly to each other and wait for replies, we introduce a middleman, like kind of broker. Okay. So something what sits between them and handle communication for us. Okay. Is a kind of a broker. This is a order. This is a payment. Okay. He will take care. Okay. Okay. So kind of, for example, this is an example. think think of think of it like a postman. Okay, one postman will be there. One postman is there. Okay, this postman will collect the letters from somebody, one person, customer. Okay, he will sort out all the letters. Okay, so when you are order something online, the seller doesn't personally deliver the package to your house. Instead, they they hand it to a delivery service which ensure it reaches to you. Is it so? Right? So similarly, if you are returning a package, if you don't fly to another city to hand it over to the seller, so you drop it off at a post office and they take care of rest, right? So one letter is there. This letter you want to post in post office. After that, you should not wait for until the process completed, right? So just post your letter inside post office and you'll go back. Correct. Remaining rest things will take care by post office people. Okay. So they will pack the packet and they will distribute this letters to some respected area. Is it correct? Right? So Kafka is like a post office. Just imagine. Okay, is just you just imagine that Kafka is like a post office. Now, instead of the order service calling all the other services directly, it hands off an event to Kafka. Okay, an order was placed for this customer with these products. Okay, so then it moves like it moves on without waiting for a response. Kafka ensure that the right service get the message, just like a post office ensure that packages are delivered to the correct address. Okay, so it's a kind of one example. Okay, Kafka is a highly scalable system for managing event logs. You understood? Huh? Official document, if you want to see, you see introduction of Kafka. See, Apache Kafka is an open source distributed event streaming platform used by thousands of companies for high performance data pipeline streaming analytics, data integration, and mission crucial applications. Okay, it is stating that clearly it is stating. Okay, you can understand from here itself. Okay, so there are actually event streaming. And event streaming, it is digital equivalent of human body central nervous system. It is the technical foundation for the always on old where business and increasingly software defined and automated, and where your software is more software. Technically speaking, event streaming is practice of capturing data in real time from event source like a database, sensors, mobile devices, cloud services, and software application in the form of streams and events. So this is actually perfect definition. Okay, storing these events streams durably for later retrieval, manipulating process and reacting to the event stream in the real time as well as retrospectively, and routing the event streams to different destination technologies as needed. Okay, event streaming thus ensure a continuous flow and interruption of data so that right information is at the right place at the right time. So this is Kafka. So you can understand the highlighted one. So you can understand the highlighted lines. Technically speaking, event streaming is the practice of capturing data in real time from event sources like database, sensors, mobile device, and cloud services, and software applications in the form of streams or of event. Okay, it will capture the data from so and so resources. Okay, it will collect it. Okay, and storing these event streams durably for later retrieval, manipulating process and reacting to the event stream in the real time as well as retrospectively. Okay, so this will give clear cut idea. Event streaming thus ensure a continuous flow and interruption of data so that the right information is at the right place at the right time. Okay, if still you can't understand, I will go and try to explain very much clear as much as I can. Okay, so how Kafka works? Kafka works two different words. One is events and the other one is topics. Okay, Kafka will work on two different words. One is one is event. First one is event. The second one is topic. Topics. Okay, these two are two. Just two. These two terminals. Just keep in mind. Okay. The order services creates a event and sends it to Kafka. Let's see. Let's move with the slides. Okay. So orders. So orders will be there if in e-commerce site. So customer will give you orders, right? This order service creates a event. This orders service will create a event and send it to Kafka. This event is just simply key and value pair with some metadata. Key and value. In Kubernetes, we have seen what is key and value. etcd. etcd will store a data in the form of key and value in Kubernetes. Okay, same like that, this event store will store information key and value, key value, something like this, list kind of like this. Okay, simply I'm telling the order service, whatever the order is there, this order service creates an event first. This event sends to the Kafka, that is whatever the events are there, these events will sends to Kafka. This event will store in the form of key and value pair. Okay, understood? Right. This events is just like a simple key and value pair with some metadata. Just keep in mind, this is called as definition. Okay, and producer doesn't wait to make sure message was received. Okay, it it trusts like Kafka to deliver it. Okay, just like you trust the post office to deliver your package. You will be there. You will leave your letter in post office. So then after rest of the things will be leave it to this post office. Then after it will reach to the respected candidate. It's okay. But your work is to just leave your your letter into post office. Rest of the things will be taken care by post office. Same like, so you order, you leave as event. Rest of the things will taken care by Kafka. Okay. For example, I'll give you one more example. Okay. Um, what to do? So organizing events. For example, organizing events with the topics. Okay, if every service is just to throws message into Kafka, we wouldn't become gained mess. Okay, not at all, right? Kafka organizes events into topics. I'll try to move. Okay, Kafka organizes events into topics, just like a post office has separated sections for letters, packages, international mails, etc. etc. For example, orders topic, payments topic, inventory topic, etc. Okay, so I already explained this. What is event? Event will store in the form of keys and values. Okay, an event records that fact that something happened in your business. Okay, it will record, also called record or message. So when you read or write data to Kafka, you do this in the from events. Okay, right? So the notification service is order event sends communication email. Okay, so the inventory service is the same event updates stocks levels. Okay, payment service is the same event generating an invoice. Okay, this way series works independently without relying on each other. What I'm trying to say is notifications here, this I'll tell you here. So the notification services is a new order event, right? Next, the inventory services. What inventory will do? The inventory services is the same event updated stock levels. Inventory means updated stock levels will be stored. That can be maintained by inventory data. Okay. Notification always will send. Okay. So it's the notification service always is new order. Okay, that's what. For example, Zomato is there. In Zomato, always they will get continuous messages, okay, notifications from the users. Okay, Uber is there. Okay, Uber driver will be there somewhere. Okay, with a vehicle. So he will wait for the orders. He, okay, that communication in between. So I'll try to explain you clearly. This is actually Uber office. Okay, so these are all customers. Okay, lot of customers will be there in the different area. This is one area, this is one area, and this is one area, and this is one area. Okay, so drivers will be there. This is a vehicle. Okay, this is a vehicle. For suppose drivers always they will store here, this is one vehicle, this is one vehicle, this is one vehicle. Okay, vehicles will be there everywhere, yeah, or two wheelers. For suppose, so these people directly will connect to the Uber app. So everybody has should have Uber app. That app should be connected with the Uber service. So what they will first do, this user will request to this Uber. This Uber company will this it will be assigned to this driver. Okay, how does it happens? First this notification. So whenever this user want to this Uber service, this notification will go to this Uber office. So Uber office immediately whenever get a notification, okay, so then immediately inventory in the sense Uber's drivers will be ready, right? So whenever whoever free, so that will be it will analysis, they will do analysis, they will find the free drivers, so they will assign these drivers, and after assigning the drivers, this information will go to the user. So this is how it will works actually, using this inventory notification analysis. Okay, all right, this is the way service works independently without relying on each other. Okay, so right, that's fine. Okay, and so as I explained, right, same like this. So 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 and here in this slide, if you see, so as I told, so it can be just like a broker, as it will be delivered to the right service. Okay, so and all this will happen in the background like a post office, as you can take it as example as post office. So you just drop off your package and go home. So don't wait sitting and checking everything, right? Same something like that. Basically, services that produces event and hands it over to the Kafka is called producer because of it produces the events. So these are all events. Okay. So and in code, this is how it will works like in using Kafka producer API like this. Okay. So it is in JavaScript or Java code. You basically use that API to create an event and give it to the Kafka. Okay, this is what happens actually. Okay, it doesn't matter about JavaScript or Java. So it will be in the form of Java or JavaScript. So you basically use that API to create an event, give it to this Kafka like this. Okay. Now, where does information or these events get saved? When producers of these events give them to Kafka, because we have bunch of other services like inventory, payment, and so on, right? That also produce certain events and hand it over to the Kafka with all the information that other services may need. So when inventory gets updated or the payment service says that payment just failed and so on. So do all these events from different producers get dumped into gained bucket in Kafka. Okay, or they actually organized somehow. If we had a big bucket handling in the writes and the reads, okay, it will not be very perf performant, right? It's just like having one single queue in the post office. For example, I will show you here. For example, lots of events will be there. So, so I have actually this is um, order place. So lot of orders are in queue. For suppose if it is in single queue, what happens? It will take a time. So we have to split like this. This is one. Half of the people out of 10, you can make 4 here, 3 here, 3 here, like this, right? So instead of imagine that post office will add sections with their own queues, like a section of letters. Another one is for large packages and so on. I will move this. Okay. So for example, this is actually uh, order delivery for suppose, or letter or package or post office or whatever. So if there is a one store, so these people should be in a queue, right? So one after the other, one after the other, one after the other, you need to complete. If you want to get the time to last one, it will take a time, right? So instead of doing this, so we can do like this. Okay, you can make it bifurcate. So instead, imagine that post office will add sections with their own queues, like a section of letters, and another one for large packages, another one for so on, something like this. If you make some bifurcation like this, so it will be easy, right? So Kafka has what's called topic to group that same type of events. You understood? Okay. So we can make it as a groups. Okay. So in Kafka also has it's called topics to group that same type of events. Okay. So example, I'll tell you order, if you for example, order service will write events to order topic. The payment service may update payments topic, like this. You understood? This inventory topic may update as a inventory topic. Order topic may update as a in order topic, and payment related you will keep payment related topic. So different as like post office, you should not be in a one queue. Make it as a different queues. So then you bifurcated separate. So it is easy to complete, right? That's how we bifurcated inventory, order, and payments into different groups: inventory group, order group, payment group. We can call it as, actually technically we should call it as a topic. Okay, payment topic, order topic, inventory topic. Okay, right? So now what the order service added into event to order topic? What happens next? That event may trigger to the actions. Let me try to take. See, so this is like topics has been divided. How to create the topic first? Huh? So who defines them? How to do that? Just like define SQL schema for your database on what application need and objects you have. You as an engineer decide how groups these events in Kafka, what topics are. Okay. So now what the order services added an event to topic, order topic. What next? That event may trigger other actions like updating stock in the database because we just sold something, or sending notification to the customer, or updating invoice and sales status. Plus, what other topics may exist that would need to be that would need an event data entry as a result of order, so which will in turn trigger that actions. Okay, so how does all this gets handled? On the other side of events, we have customers, basically microservices, who are subscribed to these different topics. These topic uh, uh, this topic related discussion we have done in CloudWatch. You might have, if you go through that in in AWS Cloud. So we have a topics information, and whenever a new event happens and it gets added to the topic. Okay, whenever new event happens, it will be added into this topics. Okay, all the consumers who are subscribed to get notified by Kafka. Okay, and they do their stuff. Okay, right. So in this case, we have three microservices that subscribe to order event. Okay, right. So notification service. First one is notification service. First notification service will see that a new order events was added, which means an order was placed in the in our application or not. And based on the payload of the event, it will send the confirmation email to the customer and maybe purchase notification to this email. That's what notification will do. Okay. Then inventory service. Then these inventory service may update the database by updating the stocks of every product that was sold in the order. So you might have 10 orders. For suppose in inventory you have a 10. Okay, so you already sold 5 to the someone. So data, how much do you have? left with you 5, right? So this inventory information will be stored in inventory. Okay, and maybe in the addition to that, database will update and it will generate a new event and write it on into an inventory topic. Okay, it's get update and delete updates happens, and this automatical update or deletes happens through this. So like this order, this orders will go, and after that it will bifurcate notifications whenever it gets. What inventory will do is, yeah, I have five something, okay. So now what emails goes to the through notifications to customer. Okay, after that, yeah, okay, order will taken. After that, payment will be done. Okay, so and then finally payment will be done. After that, what happens? Invoice will be generated and send it to the user or customer. So your business is doing great like this, but it might do even better with code. How? I hope you are learning a lot. This topic related to topic and Kafka related. I hope you understood this. Very much clear for you. I hope so. So it takes us, okay. It takes too much time for me to make it all these things. Kindly subscribe, okay. And so I want, so we have been discussing about this inventory. I sometimes I said, so this, it will inventory information database will be stored in data. So, but do you think this inventory related information, everything storing, okay, which means is this database, huh? Which means Kafka is a kind of database. This is a big question for you. Is it so? Hmm? I hope so. Many people are people will think about this. You are talking about inventory and storing the information and releasing the information, updating and deleting. Is this things happening through inventory? But might some people will think that is this kind of a database? Is that Kafka is a replacement of database somehow? Do you think that? Since we are saving all the data as events and basically updating the status of things, this is happening, right? Okay, so it's a kind of new way of savings. You got doubt? Do you think that is it's a new way kind of database? So Kafka is a kind of database. So you just question yourself, just think, okay, it is a kind of a new way of saving database or not? This is a simple question. Answer is, the simple answer is no. Okay, Kafka not a database. This is the answer. Kafka is not a replacement of database. I will explain by following one story. Okay, when someone when the inventory service updates the stock for each product database, why does it produce an event and write it to the inventory topic? This is a question. Okay, what kind of event maybe, and why would we have in addition to that data in the database? Okay, that's another use case of Kafka, where one event basically creates this chain reaction of events when multiple things need to happen. As a result, event happening. Okay, so it's a chain system. Okay, it's a chain reaction, one after the other. So where an event basically creates this chain reaction of events when multiple things need to be happen. It's a result of event happening. So this process, this chain process to be happen. Okay. So when we saw one example, so you might have another service that is subscribed to inventory topic and calculates whatever any of these products just gone below the inventory threshold and produce a low inventory alert, which may be a chain reaction. Okay, will trigger another service. One service, one is this is one service, it is triggering other service, one service completion, next it triggers to the other service, after this, after this, right? It's a kind of chain reaction. It will trigger another service that may trigger an inventory restock service that will order more inventory of that specific product. Another very important use case of Kafka is real-time analytics. Hmm? Right? So, so when a salesman when a sales happens in your application, you may have a sales dashboard where your service is updating real-time sales numbers. Another such use case is driven location updates in an application like Uber. Already seen this example, right? Previous I explained where the driver location changes and it sent to the constantly to the application, which then it will update UI of Uber and display these changes. Is it so? So Kafka producer gives to this order the form of inventories. Sorry, okay, this events. Okay, so then this inputs it will be goes to Kafka upstream app. Okay, then this happens, the cycle happens. After that, so this dashboard's external system output stream will be recorded, right? So this is what I'm trying to say. So whenever a Uber driver location updates in the application like Uber, so where the driver location changes gets sent constantly to the application. Uber, this driver always continuously, one second, he will move the location, right? Continuously. Driver location will be changes consistently. He was there here. Later after that he moved here, here. Okay. So he will be moving here and there, right? Where the driver location changes get sent constantly to the application, which then updates the UI of the user to display those changes. Okay, and for all these use cases, Kafka actually uses what's called is stream APIs, using stream APIs. Okay, so you have these regular customers that will process one event at a time. For suppose, for example, a notification service that will read an order event and based on that will send an email to the email and notification to the customer. Okay, streams. One on the other hand will process continuous flow of data with agreement aggregations and joins and so on order to deal real time processing and analytics on that, so right. For example, low inventory validation to check constantly with every event and do the calculation to see whether inventory just dropped below the threshold or get the location changes from the Uber drivers. Okay, so these analytics services will stream the events continuously doing various analytics and calculations on them. So in code, how would have stream API that will read the orders and do all these kinds of calculations on them? I'll show you. I think I'm not those. Hmm? Right? This Kafka stream API is matters, so that will show you UI. Right? This API Kafka stream API. Okay, this API will read orders and do all these kinds of calculations on them. Stream of constant data saved as a events in Kafka. Okay, so if you have an application like Uber with millions of users and tens of thousands of drivers with their locations getting updated constantly, that a lot of data and events that are being produced, right? And all consumers need to read them, right? So all the consumers need to read from it. So all millions of writes and reads in different Kafka topics, which can of course effective performance. So we need to scale, and that's where Kafka partition concept comes, which is kind of core Kafka ability to scale and become really performance. Okay, so partitions are basically what makes, so this continuously it happens continuously, the key value stores streams happens. Okay, so what is exactly it streams? It's kind of key value pair, right? So next one is partitions. So what is partition? We need to scale, and where Kafka partition concept comes in, so which is kind of a core of Kafka ability to scale and become really performant. So partitions are basically what makes processing large amount of data easy to handle and process without compromising the performance. This is matters. Okay. So partitions are basically processing the large amount of data easy to handle and it process without compromising the data performance. Okay, right? Okay. So how does it works? How does it works? Exactly with our past, sorry, old experience. I mean, old example. So our post office is there, right? Example. Remember, we edit sections for letters, large packages, small packages, so on. So bifurcated like that. So partitions are like adding more workers per section to help out. So suddenly before some any festivals happens, the letter section gets overloaded because everyone sending letters, right? Maybe some in US, all these Europe countries. So suddenly before Christmas, the letter sections get overloaded because everyone sending letters to some Santa kind of person will be there, right? I am not sure about it, but it's okay. Fine, Santa, I think so his name. So well, all right. Suddenly that doesn't happens, but if did, so we would add more workers in the section, but not just randomly. Okay. Okay. Instead, you say we can make it as a partitions. Correct. I think I did not do this. Partitions. Yeah, this was the example. Letters, packages, special packages. Okay. So yes, suppose so we have Europe, US, Asia, all these letters to be spreaded, to be distributed. So instead you say Sachin process letters going to Europe. Sachin in the sense I'm just a big fan of cricket. That's why I'll use only cricketers' names to my okay. And you can call he's a Sachin Tendulkar. Okay, he is like MS Dhoni. He is like a Virat Kohli. Okay, Sachin process letters going to Europe, and Dhoni handle letters to these US. US means United States, and Kohli handles letters to Asia. Asia. Some people will call Asia. Some people will call Asia. All right. Okay. So same way in Kafka, in orders topic, you may create EU. It's a kind of one topic. US. It's a kind of one topic, and Asia is a kind of one topic. So like this, right? Say so. And again, you would decide how partition your topic as part of your schema design. Okay. Now let's think about customer side. Okay. Let's say suddenly millions of orders are coming in continuously, millions and millions of orders are continuously getting in. Okay. Right. So then, and we said we can scale those partitions so producers can write into multiple partitions as the same time, right? But what about the consumers? How can they consume so much data at once? Hmm? Right? Because even if you have a partitions, you have one customer, sorry, consumer. Let's say inventory service trying to process all the events that it's subscribed to, which is like all the parcels going to one person recipient, like thousands of letters going to Santa. Okay, so those post office workers are being super quick and are delivering them to recipient, but he is getting worried under the files. Okay, but we need some people helping them sort through this, right? And this where consumer groups comes in. So when you start additional instances of that microservices like replicas in Kubernetes, you might say. Okay, so in this case, whenever traffic is continuously increasing at the time in Kubernetes, in Kubernetes, right? In Kubernetes, we have replicas. Okay, so they can call consume Kafka partitions. So these replicas will produce, it will generate another container. So it's not topic about Kubernetes. Let's move on. So just for example, I'll mention. Hmm? Right. So Europe, US, Asia, all these inventories have been separated, right? So yes. So now whenever traditional instances, sorry, whenever additional one sec, whenever additional instances of the microservices like replicas, the Kubernetes, they can all consume from the Kafka partitions and process events faster parallelly. Replicas, right? Now, how does Kafka know which consumer from a group and how to divide and which one is belonging together? So, this is one replica, this is one replica, this is one replica. Okay. How does Kafka knows the consumers from group, which group, how to divide, and which one is belong together? Okay, simple. It's very simple. They are grouped by group id, grouped by group id. Okay, so and attribute when the register as consumers with Kafka, so replicas of the same application will have the same group IDs and will automatically be grouped together. So like this. Okay. So and when you start replicas, Kafka distributes the load automatically by assigning partitions to consumers. Okay, like this. So when you start replicas, Kafka will distribute, okay, the entire load automatically assigning partitions to the consumers like this. It is actually here, you see, this load and this load is distributing. So this load is distributing to consumers like that. So for example, if other replica adds, what happens? For example, in this previous one, if you see the previous one, so here you have a how many? Three. One, two, three. Replica one, replica two, replica three. For suppose you have three different topics. So US and Europe, Asia, something. So whenever it is enough consumers, enough groups are there, then it will distribute the groups like this. But all of a sudden, if something happens to this, then what happens? This will be divert to other replica. So this replica will handle this. Understood? Right? Like this. Okay. So when you start replicas, Kafka will distribute automatically. So Kafka says, "Oh, we have a new helper." Okay. So now you can process these pile of letters here, and when that helper stops working, it will take the pile and give it to the other active one, which means I already told you and show you, if this not properly working, then it is, you just divert to other. Okay, just give it to another active one. This is active one, it is not active. Okay, so responding to the email takes time, but not with, right, but it will not respond, but it will divert to the other one. Which one? This is active one and this is active one. You can distribute near one, anything. So Kafka will take care that loads, right? I hope you understood somewhat better, at least. Like this, Kafka distributes a load automatically. Okay, it's a kind of load balancer. Okay, DevOps people can understand this. So where is the date physically saved? Where? It's not a date, I'm sorry, excuse me. Where data physically save? Kafka broker. Okay, using Kafka broker we can save that data, definitely. Okay, so physically where we can save data? Kafka broker, keep in mind. So, and you can think of each broker like a post office branch that stores the actual messages on disk. It's not disk, it's a disk. Sometimes pronunciation, try to understand. Handles, okay, it handles request from producers and consumers and replicates the data of fault tolerance. Okay, so server that stores the data in topics manages messages distribution to the consumers. Excuse me. Right? So even if something happens to the disk, the data will be stored somewhere else as a backup. You understood? There will be a backup also. And it is actually what makes Kafka different from standard message brokers. Okay. So other competitors also are there, right? So you try to understand here what is Kafka broker? Server that stores the data in topics, manages messages and distributes to the consumers. Okay. So what fault tolerance? Topic partitions are distributed across multiple brokers. Each partition has leader broker and multiple replicas. You can see the picture. Okay. The first one, that black color one is, you can say that is actually Kafka. Okay, server. Kafka server, you can say. Imagine. Okay. The Kafka server, this one. And it is containing with the disk. Okay. This is a disk. Topic A we have created, topic B created with the broker one. Okay. Same way we have created broker 2, broker 3. Okay. Even something happens to the disk, data will be stored as a backup. Even something happens to disk, so backup will be there. That backup has been provided by Kafka. Okay. Okay. So you understood this fault tolerance. What is fault tolerance? If something happens, okay, okay, one second. The topic partitions are distributed across the multiple brokers, broker 1, broker 2, broker 3. Each partition has leader broker, right? Yes, each partition has leader broker. Okay. So, and multiple replicas also. Each broker like a post office branch that stores the actual messages on a disk, handles request from producers and consumers, replicates the data fault tolerance, for the data fault tolerance. Okay. Fault tolerance means if something happens, if fault happens, to be replaced by something, it will be replaced with other replica. So while regular message queues would delete messages after consumption, so as soon as consumers see that message and do something with it, message is gone. Okay. However, the Kafka will take care. So persistent data will be there. One sec. Okay. So Kafka, what it will do is, so it will persist every event, which means it will persist in the sense backup kind of. It will persist each and every event or messages as long as you need, and you can configure how long you want to store them with a retention policy. Okay, you just keep in mind this. Persist every event or message as long as you need, and you can configure how long you want to store them with the retention policy. Retention policies we have explained in the Kubernetes. Okay, so just think of it like our post office keeping a log all of package deliveries, but not just a record keeping, but for analyzing patterns and improving service also. Okay, so that unique features of Kafka for real-time data processing and general analytics means that Kafka needs to store those events long term so that consumers can read those events anytime they want, even multiple times if they want, they can need to. Okay. So as I said, this capability to process streams of data in real time while keeping the original data for later analysis is that really differences Kafka from simple message brokers. Okay. So for Kafka, For Kafka, RabbitMQ and ActiveMQ. So these are all normal message brokers. Kafka is completely different from that. Okay, okay. Let's see the difference. Okay, normal RabbitMQ and ActiveQ. These are all normal brokers. Okay, Kafka is too different. So in this architecture is completely different. This actually messages are deleted after consumption. Okay, but it stores the messages on disk configurable retention period till that it will be store the messages. Okay, right. So this enables real-time data processing. Consumer can read multiple times and whenever they want. Reply of messages, debugging of historical data, etc. etc. Okay. So in Kafka, focus on event streaming and long-term data retention. Also optimize for high throughput and normal these RabbitMQ and ActiveMQ. So designed for message queuing and point-to-point consumption. Message handling is more transactional, prioritizing and reliability over speed. Okay, right? So I will give you one small example here. Kafka and RabbitMQ. So normal standard messengers. Okay, message brokers you can call. So RabbitMQ, ActiveMQ, Kafka. These are all normal. RabbitMQ and ActiveMQ is normal message brokers. Kafka is too different. Okay. Here one I will take one example. In Kafka, they are using Netflix for suppose. Okay. So that main difference is even a clear comparison between Netflix and normal watching TV. Example, I'll tell you. Netflix is a demand, right? Netflix is a very demanding application. Okay, you can say. Okay, so consumers or people who are viewers, they can decide themselves what they want to watch. Is it correct? Example, movies, sports. And I'm not sure about both sports, but comedy zones or thriller, horror, something different like this. Okay, for example, pick comedy. Okay, so I'm watching this a movie. So for example, I had some little work actually pending, so I just simply remember I got or else it got disturbed or interrupted by someone or something like this. So you can able to pass your movie later. Once or after finishing that work, you can able to continue that. Is it so? Yes, 100%. So consumers or people who are viewers are there, they can able to decide themselves what they want to watch and when they want to watch and what pace, what kind of genre. Okay, they can able to stop it, they can able to pass it, and anytime anywhere. Okay, and anytime they can able to continue whatever they want, or they can reply or start from the beginning. They can also do that. But as compared to that, normal brokers, okay, normal message brokers, for example, RabbitMQ and ActiveMQ is there. They are actually giving the service to the TV. Okay, if you take normal TV, so you have a predefined programs, and people who want to view those programs need to tune in the specific time to watch the specific stuff. Exactly, right? So everyone watches the same thing at the same time at the same pace. Okay, so you can pass and continue later. So if you miss it, okay, for example, something is moving, some program is going, so you miss it in the sense, yes, definitely you missed it. So it will be telecast at the time all the places at a time. So once if you miss it, definitely it will move. Okay, right? So if you miss a movie or show, you just missed it. That's it. And it's not automatically saved to watch later. Definitely there is any option. And that exactly the difference between Kafka architecture versus traditional message brokers. That is the difference. Okay, this is giving a great service. Kafka is giving great service to Netflix. Amazon Prime, example, Netflix, okay, AHA, and Hotstar, like this, okay, and that exactly the difference, same difference we have seen, okay, and finally, Kafka needs a way to keep track of which broker are live, okay, elect leaders to coordinate, manage all the configuration, and traditionally, Kafka uses an external tool called Zookeeper. That is also is there. I will show you here. Okay, this is a Zookeeper. What is Zookeeper? So maintaining a registry of all active brokers in the cluster. Okay, okay. So exactly the difference between Kafka architecture versus normal broker, there is a clear understanding. I think you have seen clear understanding. You might have understood. Okay. So what is this Zookeeper now? Kafka needs a way to keep the track of which broker are live. Okay. It will elect leaders to coordinate, manage all the configuration, and traditionally Kafka used an external tool called Zookeeper for type of coordination. For coordination, Zookeeper is a kind of tool which is provided by Zookeeper. So it was like a central management for all the Kafka brokers. Okay, important note it is that I will show you. This is actually Zookeeper. Zookeeper is a centralized service for managing metadata and coordination task for distributed system. External dependency of Kafka. Okay. So here Kafka removed dependency on Zookeeper. Okay. So new version of Kafka from version 3 introduced Craft or Kafka Raft, which removes the need of Zookeeper as its external dependency with the centralized control by building with that coordination directly into this Kafka. Okay, you understood? I hope this made clear for you. Okay, right? So I will give you some little differences. Like, so Kafka is actually real world summarize actually. So Kafka is the real world. Kafka is the real world, right? Kafka is a powerful event-driven system. Am I right? So it will decouples microservices services preventing system failures. It scales efficiently using partitions and consumers groups. Enables real-time processing for analytics and automation. It ensures fault tolerance with persist of storage and replication. Okay, you understood? I hope you understood. So if you summarize, so understanding Kafka with the real world already we have seen, right? So we have taken one example Kafka, like e-commerce platform, which is name called Stream Store, online store. We have seen different services handling payments, orders, inventory, and so on, right? This one using Stream Store. Okay, okay. this post office related, and so how this Kafka is working for inventories. I mean, how this Kafka is working for e-commerce websites and e-commerce apps. Okay, inventory. What is inventory? Notifications, billing, and analytics. All this, right? For our startup companies also. So tightly coupled architecture also we have seen. For example, if it is tightly coupled with each other, if any service broken happens, then remaining service also will be affected simultaneously, right? To overcome that. Okay, so application crash will be happen. For suppose if happens that, so what will happens if crash happens the application, definitely complete architecture might get down. So application might get down, it gets slow. Okay, so application might not works. So then definitely service may get down. So that will be the problem with the tightly coupled. Okay, so that is the reason there is a concept called as Kafka with the broker. Okay, the middleman. Broker is actually a middleman. So he will always go for, he will always seeking for the orders. So he will always give the payments. So Kafka is middle between the orders and payments. Okay, so same like we have shown some post office examples. Okay, something like post office examples we have seen. So we have seen about orders, what is event. Okay, how does it works. So it will takes the orders and it will be it will goes to the event is actually kind of a key value pair, and after that it will send this to Kafka. Okay, it's a kind of key value pair. So key values, it will store in the form of key and values, kind of etc. I given one example, and an event records that fact something happens in your business. So this we have seen what is record and all, right? So API is related also. How this API, okay, what how this API worked with it, how it is acts as a API. Okay. So this main concept we have seen that post office, if different services we have, if you want to keep in one queue, what will happen? So if you distribute that queue into three different parts, so we can make it easy, right? Same way we have made some three different groups like topic, okay, inventory topic, order topic, payment topics, like that, right? So yes, orders also given. So what kind of consumers we have? We have some three different services called notification, inventory, and payment. How does it works? So we have seen that also. Hmm? Right? So we have seen that also. So also we have discussed about Kafka. Kafka is a replacement of database. Never be. Okay, it's not replacement of database. Okay, so we made this some different groups like a topic. So if you create a groups, that groups, say inventory group, so we make it as a topic. So inventory topic, order topic, and payment topic. So okay, we can make it as different. Okay, so change event means, so services will be one after the other. It will come once complete one service complete other one complete other one complete other. So it will be kind of triggering one after the other. It will trigger one works complete the other. It will go for other. Okay. So what we have seen, what is a Kafka producer, what is Kafka consumer, and this process we have seen all. Okay, we have given the Uber as an example. Okay, so and partitions also we have seen. Okay, what type of partitions are this? So right, so partition scalability and performances, right? So that's all. Consumer groups also we have seen. What are the groups, how these groups are working, as what is replica set, and if any, if it is anything fails, any replica fails or down, so then again it will goes to the active one, something like this, right. So we have discussed about two normal message broker and Kafka. What is the difference of it? What is the difference of? I have shown you example related to Netflix and normal TV, right? So this is a kind of, this is all about Kafka. Okay. So I hope you understood. Thank you so much. Thanks for joining and Thanks for watching my video. If you are happy with it, kindly share and subscribe, and also kindly do like. If you do like, so it will goes to different people in different communities. It will appear to many people also. That will help for me, because that will really motivates me for doing more kind of videos type of Kafka and all. So I'm moving forward continuously without any disturbances, and whatever hurdles happen, it will happens, but I'll move forward with different topics. I'll continue with it. So kindly support me more. So kindly simple, I'm just asking and requesting you, just simply like it, nothing, don't need to share also, kindly just simply like it. That's it. No need to do anything, no need shares and all, just simply if you see my video, just simply like it. It will appear to many people. That will help, that will really helps a lot to me. Thank you so much, thanks for joining. Until then, I will see next video will be Congo. Okay. Okay, we will see in that video. Until then, take care, bye. Take care.